Okay, pyramids and cones. Pyramids and cones are very similar to a prism or a cylinder, but also very different. The major difference between the pyramid and a prism is the fact that a pyramid has one base and the prism has two. So as I look at this, I see that we have only this one base here. It is a rectangular base, so it would be a prism. Whereas my other example that we'll do, we have a circular base that makes it a cone. Okay. Our formulas are listed up at the top. They'll be listed on tests and quizzes, so the main thing is understanding what each of our four variables represent and how to find them. So the first one is capital letter P. That is still the perimeter of our base. The base in this case, we will always look at in a prism, our base being a square, regular polygon. So if it's 4 sides, it's a square. If it's 5 sides, it'll be a regular pentagon. In this case, I just know that part of it is 5. That part is going to be half of one side length. So each side is 10. Perimeter is going to be 10 plus 10 plus 10 plus 10, or in this case, 40 meters. And I've got slant height listed there twice, so we will fix that. Slant height is going to start at the vertex of your pyramid, and it is going to go down one of the lateral faces, perpendicular. It is a perpendicular bisector to a side of the base. And it goes down a face. The edge goes down between lateral faces. So in this case, I have been labeled my slant height, which is this cursive L, of 12 meters. The base, or capital B, is the area of the base. This is a square. It's going to be 10 times 10, which is going to be 100 meters squared. And then I'm going to actually erase that, because the one that we have to work for here, the one that's not necessarily given, is our height. Height also starts at the vertex, but this time it doesn't go down a face or an edge at all. It's going to go straight through the middle of your object, of your pyramid in this case, and intersect the base. So it is perpendicular, and it's also going to be a bisector, but right down the middle of your base. So if the side is 10, then I know each of these is going to be 5. That's cool. It's also really important because I have a right triangle in here now. That's my height. I'm looking at a right triangle where I have the height here, I have a length of 5 here, and I have the slant height is the hypotenuse. In this case, that's 12. So height squared plus 5 squared equals 12 squared. And then drum roll, please. No drum rolls? Okay, no drum rolls. We wind up with the square root of 119 meters. Just leave it as a square root if it happens to be a square root. If it's a perfect square, take the square root. Okay, so my height is square root of 119 meters. I know all of my pieces. I can now find my surface area and my volume. Surface area is going to be equal to the lateral area, which is 1/2 of my 40 times my slant height, so the perimeter times my slant height of 12, plus the area of one base, which is 100 meters squared. I'm not adding 2 times the base because there is only one base. And again, this is a calculator problem. Put that all into my calculator and I get a surface area of 340 meters squared. Volume, I plug into my volume formula. It's not area of the base times height like in a pyramid or like in a prism. It's 1/3 of that area, which is 100, times the height, which we said was square root of 119. Leave this as an exact answer. 100 times 1/3 gets me just 100/3. I don't have to estimate that, and multiply that by the square root of 119 and I get the square root of 119. Not 19, but 119. That's an exact answer, and I leave it in meters cubed because this was meters squared times meters. That gets me meters cubed. For a cone, the idea is the same, it's just a different base. I'm still going to have to find my perimeter of my base, but my base is a circle, so the perimeter is going to be the circumference, which is 2 times pi times my radius. Radius is 7. 7 times 2, I get 14 pi centimeters. Slant height is already given to me. It's 25 centimeters. Area of my base. Well, the area of the base is going to be the area of your circle, which is pi r squared. So the area of my base is 49 pi centimeters squared. And my height. Height, again, is going to be at the vertex, drop right through the middle of my cone, and be perpendicular to its base. So I have a Pythagorean theorem problem here again to find my height. Height squared plus 7 squared equals 25 squared. Pythagorean theorem once again. This time I get a perfect square. I'll get 25 squared minus 7 squared. Square root that, I get 24. So my height is 24. Now I can plug into my equations. Surface area is going to be half of my perimeter, which is 14 pi, times the slant height, which is 25, plus the area of one base, 49 pi. I want the exact. If it doesn't say exact, assume exact. When I put that into my calculator, I get 224 times pi, and this is an area, and we're using centimeters, so it's centimeters squared. For my volume, it's 1/3 the area of the base times the height of the cone. Again, doesn't say exact, assume exact, unless it says estimate, or if we're comparing. Here we're not comparing anything. 392 pi centimeters cubed. Again, volume is cubed, surface area is squared, because this is 14 pi centimeters, 25 centimeters, and this is already centimeters squared. That gets me centimeters squared plus centimeters squared, it's centimeters squared. 49 pi, we already talked about, is centimeters squared, 24 is centimeters, so centimeters squared times centimeters is centimeters cubed.